We're going to have the BitMind team up here. Lovely to see everyone in the audience. Hey, James. We got Dub. Let's just do some mic
What's up,
tests.
everybody?
Some minor updates from OTF side. We're just pushing to testnet a bunch of changes that stabilize the RowNet, specifically around accounting dividends. It's looking good. The test is running quite well right now. There may be some final touches that we make over the next little while that change the dynamic. We have a paper coming out in the next week or so, and then as soon as that's out and there's a bit of a comment period, we'll just go straight to mainnet with DTAO, which is very exciting. So we're definitely very excited behind the scenes here about what we'll be able to launch very soon for the community. If you have questions about that, we can leave them to the end of the call. People can come up on stage and ask questions about the RowNet that we launched last week, or say the week before last. And yeah, we'd love to have a conversation about that. But this specific novelty search is for BitMind. And we have a presentation from Ken, Eli, and Dub M here. So yeah, I guess without further ado, why don't we jump into that? People will file in, but we can have this conversation while they do that.
Sweet. Yeah. Thanks for the intro, Const, and thanks for having us on. All right, let's see if I can share the screen. Cool. Hey, everyone. We're going to be presenting BitMind, which is Subnet 34 on Novelty Search today. I'm Ken, one of the co-founders of BitMind, and yeah, let's just get into it and start the conversation. Okay, so what do we do? What does Subnet 34 do? We do AI-generated content detection, and this has become AI-generated content has become increasingly difficult to detect, and it's really challenging, the fabric of trust in society. And the goal that we have is to create the most accurate and authoritative deepfake detection system in the world, and doing that through Subnet 34. So why is this important? Right, a lot of the elections happened this past year. There was a lot of current events. There's a lot of conflicts around the world right now, and society is based on trust. Even fiat money is based on trust. That is some backing of trust in our societal fabric. And can you even tell what is real anymore with now the proliferation of AI generated content? And this goes both ways. So you have you're seeing some wild news happen. The Trump assassination attempt, is this real? Some conflict in the news, what am I looking at? There was a report that over, I believe, 70% of some of this conflict news that was happening in the Middle East was either, images or video from past conflicts, or not actually what was going on the ground. And then you have stuff that, it is actually real, but people think it's AI generated. There's a bunch of coins. I think Caitlyn Jenner launched a coin, and people were saying, no, this is definitely AI generated. It happened to be real. And there's plenty of examples like that. And so what it came down to in the genesis of this idea was, if you really can't trust what you see and hear, this has the potential of really eroding the fabric of humanity and how we communicate, how we interact with each other. If you are consistently questioning what you're looking at, what people are telling you, what information you're consuming online, one, it creates a very inefficient society because you have to do additional research, verification, etc. But also, it just creates a very Black Mirror situation where I think there's just massive distrust that we've already even seen in kind of traditional media and a lot of media that's happening right now. Okay, now after kind of outlining that problem and why it's important, how do we evaluate trust? How do you determine source of truth? Trust is a very interesting word because it means different things to different people, or truth, that for that matter. So a truth for someone might be different from someone else. In this case, how we defined truth in the digital content space was, has this piece of content been touched in any way by AI, or is it completely generated by non-AI tools? That was our binary classification. And so what we use to evaluate this is open source real data sets, AI generated data sets, and we have a very sophisticated data generation pipeline to create these at mass scale. And then the last is real world data contribution. So you can think of people submitting images, video, all types of multimodal content with verified in application services, so that it hasn't been tampered with or messed with. All right. Before we go into some of the details about kind of how the subnet works, what are some of the technical details, kind of think it would be important to scope where we're at right now. How well is this working? Is this good, or is this something that I should care about? So to start, this is something we released called Deepfake Detection Arena, and what we wanted to do here is to provide academic rigorous benchmarking for the models that we created. And so you can we'll provide the link after the novelty search to this Hugging Face leaderboard and the paper that we released with it. But essentially, there were two state-of-the-art models in deepfake detection that were popular and well cited in academia, called Neighborhood Pixel Relationship, NPR, and then UCF was the top performing model in a paper called Deepfake Bench. So what we created was a framework that utilized essentially a hard mixers of experts approach called CAMO, which stands for Content Aware Model Orchestration. And what we proved with this holdout set and all the architecture trained on all the same data was that CAMO, which is our base miner, has a accuracy improvement, is essentially better and outperforming what was state of the art in academia. It was outperforming both NPR and UCF. And so what's really amazing is that, the miners on Bittensor, the incentive of Bittensor really, really worked for us. And so since launching, we've seen almost a 20% increase in performance from that base miner that we originally released as, improve on this. And I think a lot of the miner teams that we talk to are actually using their own proprietary architectures that they're getting extremely high results from. And so now there's like a 20% improvement over those state-of-the-art open source academic papers. But what we really wanted to do, and what the commodity that we're trying to create, is really generalized deepfake detection in the wild. Can it go on the internet, see an image, video, audio file from a model that isn't in the training set, it hasn't seen before, or a real image from maybe like a camera or a place or a person that it has no understanding of, and be able to properly classify it? And so we conducted these. Sure.
Can I jump in here? Because I think I don't want this to sort of the importance of this miss. So if I understand correctly, we're 20% more accurate than all of the state-of-the-art models currently performing this same task in the world. The best from Google. Is that correct?
So, right. I would say no, not exactly, right? These are the best, I would say, open source frameworks. There's a variety of like deep proprietary, like very proprietary models, but anything kind of that is publicly benchmarked, a lot of these private companies don't release anything about their results or accuracy scores.
I see. But just by testing these closed source methods, is there a noticeable difference between the way that we're performing on this network and the way that they're performing?
Yeah. I think just from kind of like our observations of all the tooling and enterprise kind of services that are available, I think the miners on the subnet are extremely competitive, if not higher performance than, and I believe that anything that is out right now. We were really shocked by these results. This kind of 88% accuracy without any additional like aggregation experimentation, but we got it up to 91%, and that was we were very surprised by that result. I think anything that we've tested out that we've seen is
very hit or miss.
very, very hit or miss. Like,
Yeah.
I would say below 60% accuracy, just because you can throw so much different, it's a very high entropy space. You can throw a lot of different data at it.
Not only is it potentially better here, the incentives which the miners are aligning to are open, right? So, like the source of truth that we are annealing towards is not just arbitrarily decided by a closed source company.
Yeah. Yeah. There was a really interesting article that a venture fund called EV3, it was on Deep Ninja, wrote about BitMind. And this company called Reality Defender just raised $33 million. And they were talking about like basically kind of estimating their OpEx, how much they needed for compute and developer costs. And then they compared it to BitMind, which is, much smaller team, but utilizing the incentives of Tau to, right, like basically have all these different miners from around the world competing to create the best model. And, you know, it was almost like it was such a different structure, but really created some better results, we thought, of like, the actual performance of what it created. And the results are open. It can continually be improved upon. And all the data is open to continue to, which is really like a key factor in improving this. So I think we feel like we have a very performant state right now that is beating at least anything else out in the open source space. And our data sets are growing at an extremely fast rate. Our models are improving. We're making the challenges harder, where we think we can increase that gap very fast. And
What I've noticed in a number of subnets, like another example is graphite, where they're like, we have the best open model, and we think that we have the best amongst closed source models as well, but they don't want to be benchmarked against.
Yeah.
Like, because they don't want us to prove that we're better, which is quite interesting. We should figure out a way of actually breaking down that wall and figuring out how to benchmark against these teams so that we can prove. And I'm sure that we have the best. It just is always the case on Bittensor. So, anyways, I didn't want to take too much of your presentation, Ken, but yeah, please carry on.
Yeah, no, that would be interesting. Yeah, and even more so, like a lot of these are just gated. At least the deepfake detection space, they're gated behind like enterprise contracts. So you need to pay a decent amount of money for them anyway, and for them to not have open results is interesting. But yeah, would love to run that experiment someday. So now going into maybe some of the technical details for any of the folks that are interested in kind of how the subnet actually works. So, very basic overview here, right? Validators send either images or videos to miners. Miners predict a float between 0 and 1, essentially whether it's real or AI generated. Right now, it's binary classification. We want to move to multi-class, real, synthetic, and semi-synthetic, and then eventually go to localized heat map prediction. So if you have a face swap, it will know, that it will highlight the face and say that it's that this is the AI generated portion of the image. And then for the rewards, right, it's determined by the historical performance of each individual miner. And there's essentially a percentage distribution right now, both between the video and audio, but eventually with video and image, but eventually a percentage distribution between all the different modalities. And as we increase video, improve the difficulty of video, right, we'll hopefully get to some sort of balance long term. And now, this is a big diagram, but maybe you can hand it over to Dylan to explain kind of high level architecture.
Yeah, thanks. So there's a lot going on here, but at a high level, this shows both the Bittensor components, the validator architecture, the miners, how they communicate, and then some auxiliary things like our Hugging Face dataset collections, our models on Hugging Face, our weights and biases that includes every challenge and all the miner response, as well as like metadata about those images, where they came from, and also shows how all the applications connect to the subnet through our cloud infrastructure to service organic traffic. that's it kind of at a high level.
Okay, let me, let's try to make it even more high level. Okay, so take us through the life of a query in BitMind on the subnet.
Yeah, okay, so organics are quite simple. An image, or right now, like the thumbnail of a video, will be sent from an application through our cloud, where a load balancer will decide on a validator to send this to based on like geographic proximity and load and stuff like that. Before that happens, we'll actually check whether this image has been inferred on already. We've got a vector database that stores all the queries that have been through our subnet and the inference results from the miners. So if we actually find a match here through embedding similarity, we'll simply surface those results, so we're not kind of just hammering our validators and miners with repeat queries. But if we don't find a match, then we'll forward that data to the validator proxy service running on the validator, and that will simply kind of basically mock what a validator challenge looks like by pre-processing it and populating a synapse and asking miners to predict on it. That's not actually incentivized right now because we don't have ground truth, obviously, if this is coming from the internet, but the organic queries just mirror exactly what our validator challenges look like. So miners predict on them nonetheless. For synthetic or for validator generated challenges, for scored challenges, the data are always coming from this cache layer. This is kind of our 2.0 architecture that we'll get into more a bit in the coming slides, but this cache layer is constantly being populated by two asynchronous processes. One that's generating data from now 11 generative models, or the other process, which is basically doing like partial data set downloads from Hugging Face, like randomly selecting a zip file and then randomly unpacking data from that zip file. So the validator forward pass is actually really elegantly simple now. It simply decides on the modality, decides on whether it's synthetic, semi-synthetic, or real, and then samples from the appropriate location in the cache. It'll augment the data, pass it on to miners, get their responses, score them, and log everything to weights and biases. So that's the two flows with a lot of overlap at the very end with how the communications actually happen, but yeah. Hope that leaves people with more answers than questions.
There's a lot there, but effectively, you send the query to the miners. The miners respond with the prediction.
Yeah, that's the prediction. That's a short way of saying it. Yeah.
Yeah, and the prediction is true or false, basically, or is it like a probabilistic output?
It's probabilistic, but what we're prioritizing is just accuracy, right? We don't want miners like over optimizing to calibrate their the probability outputs of their models. We're more so incentivizing correct predictions.
Right. That makes sense. And so like one question I would have like from this is like, how do you guys get ground truth? And how do you do that in a way that people can't just do lookups right on your data set?
Yeah, great question. So for organics, like I said, we don't have ground truth, so we just don't score them. But for validator generated challenges, we know, all the data in the cache are either from these open source real data sets, or from all the synthetic data is generated locally on the validator. So the ground truth is just innately known by, being privy to where the data came from. And then to the second part of your question around how do you mitigate lookups, we put a lot of energy early on. We had one engineer spend a lot of time trying to game our subnet, basically by taking, all the real open source data sets are public. They're on Hugging Face. So kind of the full extent of what the real images we're going to be challenging you with are. So naturally, the adversarial miner would think, let me just create a vector database, much like the one in the cloud up in the BitMind cloud part of the diagram up there, and just try to do reverse image lookups for every image I get from validator challenges. And if you find it in your vector database, that means it's real. And if you don't, it's synthetic. We found that the data augmentation pipeline that we've developed, which is part of the validator pass, or the forward function there. It's not pictured, but it's kind of the last step before we send stuff out to miners. All the augmentations that we're touching these images with kind of sufficiently move the embedding of that image away from the embedding of the original image, such that it's really difficult, we think impossible, to outperform even our old base miners by trying to match embeddings to the original images after doing augmentations. Does that make sense?
It does. The augmentation has to be quite sophisticated, though, because surely, like you also would destroy the images potentially.
Sorry, I didn't catch the last bit.
Potentially, you're actually destroying the images that you're using for validation if you're augmenting them too much.
Yeah, correct. So it's a really fine balance in sufficiently augmenting them to kind of push that embedding away from the original embedding, but not to the point of completely destroying kind of like the forgery specific features that all of our miners have like trained themselves to detect. And so we've based, there's a good slide for this that we actually hid, but let's look at the first one, with the picture. So this picture is from a paper called Deeper Forensics 1.0, and this is specifically for using data augmentations in training models and evaluating models in the deepfake detection space. This paper focuses on faces, but we found the augmentations to serve quite well in just the generalized AI image detection space. So we've got both a combination of kind of very traditional image transforms, rotations, crops, flips. And I think of those, the random resize crop is the most important in terms of gaming mitigation, because if you imagine like a picture of a dog on a beach, and then you crop that down to 20% of the original image and all you get is ocean, the embedding of that ocean chunk is going to be quite different from something that is looking at the sand or the dog, right? So I think of those three, the random resize crop is really important. And then all the perturbations shown in that image are from that Deeper Forensics paper. And the way we apply them is by kind of sampling this probability distribution here to decide how difficult do we want to make this specific challenge. So there's a chance that the image isn't augmented other than a resize, but 75% of the images and videos that go to miners have some level of either those traditional transforms or those deeper forensics perturbations applied to them. So we've looked at, hundreds, I don't want to say thousands, but maybe thousands of augmented images, and kind of anecdotally, they're still recognizable. And when you look at stuff in the wild, there is going to be significant levels of stuff like JPEG compression. So a lot of these transformations are not only serving to improve how difficult it is to game the subnet, but also kind of more closely aligning the nature of our scored data with in the wild stuff that has been like downloaded and uploaded a billion times.
Yeah. And then what's interesting, right, about like what we do with this perturbations, I think something that was really critical that Cons mentioned was like, hey, are you doing augmentation that is actually hurting the output of the performance here? And so with this in the wild results, with this essentially service that we can benchmark our subnet in the wild, we're able to determine that those augmentations didn't have a negative effect, and they were actually improving the generalizability and in the wild performance of the miners overall, while still making it much harder to do. The lookup is essentially what we want there. And then maybe the last thing about the mitigation of gaming, we'll touch on it a bit later, but something that is really, really critical. You can create essentially unlimited AI generated data, but we have some bottleneck in at least highly curated, very well labeled real data. And so something to mitigate gaming is to essentially create infinite real data sets. that are increasingly expanding over time, so that these lookup attacks basically won't be performant. And yeah, we have something that we're really excited to share about that. Basically, of a mechanism to do that.
Well, go on. So wait, yeah, how do you solve that?
Yeah, let's just jump around and go into it. Okay.
Let's jump around. Yeah, it's a good time to talk about this.
Okay, so so what we were in the office last week, and there was another founder of a company called Adon, which does essentially like real image multimodal data collection, incentivized real image or real multimodal data collection, and they do it through this mechanism called quests, where you give a quest to any user, whether it be take a picture of your face, take a picture of a bird, speak into this in a funky accent. And so what we've done with them is partner with them so that their users are submitting a variety of different multimodal data that we're now adding to our data set that are incentivized right now through their point system. And we're working with them to create further incentive mechanisms. And so what that does for us is it allows us to have this lever of saying, hey, what type of real world data do we want? Do we want landscapes? Do we want pictures of pictures? Do we want human faces? Do we want people dancing or running? But having a lot of control over what type of real data that we can add to our data sets that we know source of truth of, and we can score the miners against, with the intention that this will improve the real world in the wild performance over time. And so, right, in here I say like the holy grail, an endless stream of real images, videos, and eventually audio is what we're going to. So we started that this week. We've collected, I believe, over like 1,000 data points so far, but trying to continue to increase that and think this is a really powerful mechanism of this is something we thought of right at the beginning, and we were like, how should we do this? And really excited about this component of it.
Yeah, I have to mention the fact that we spent more of our in-person week talking about how we could actually build something like this ourselves than than Ken would have liked. And then kind of the next day we happened to meet that founder. So it's a really serendipitous integration, because now we don't have to build it.
The data set that you're collecting here is very valuable. Like how much data have you collected at this point from your subnet?
So I think it launched it launched either on Monday or Tuesday. And I think we have like it's growing right now, but I think the last I checked, we have like about 1,000 like images and videos. And like basically we launched like these 50 different descriptions or quests. Or okay, there's tasks, and we launched 50 different tasks. And so if you go to this app, it'll be like take a picture smiling, take a video of yourself dancing, and then all this kind of stuff. But I think we have about 1,000, so it's maybe averaging around like 250 to 300 different images or videos per day right now.
Yeah, and the platform is, I think they launched it 2 months ago, so it's relatively early. So, excited to see how both we can kind of play with our levers to increase the engagement we get from their users, and also see how that corresponds to their general growth as a platform.
Good comment in the chat. We should definitely get you guys on Papers with Code, these benchmarks. Is there a reason why we're not?
No, I think that's a great idea.
Yeah, we definitely really want to. I think we're in the works of writing like more of a traditional paper around kind of like the results that we have. But we've released a couple of different, I would say academic blogs. But would love to be on Papers with Code. I think that's a great suggestion. I think the more we can get into academia, the more distribution and pressure we can put on other folks.
So where do we go from here, guys? What like we have this lead. You guys are saying that we have like 10 to 20% lead over the open source versions of detection, the moat is there clearly, and you're using Bittensor properly. What is the pie in the sky? Like where do we converge on here? Creating like the ultimate detector of reality?
Yeah, essentially and I think the important piece there is like multimodal, where it'll be interesting to see. Maybe the holy grail is this: is like can a new state of the art video, audio, image model come out? A new state of the art generative model come out, and the minor models, these detection models, have never seen it before, and it's able to still generalize it based on some of the patterns that it's seeing in that generated content. And that's difficult because, right, these diffusers have different architectures. They're all different. But I think that would be like really amazing if something like new state of the art, people were shocked. The human perception was shocked by the performance of it, but the model could detect it without any additional training data.
Right. Because we're not quite there yet. Like you could still detect, just as a human, AI generated images pretty well, like especially videos. But it feels like very soon the lines are going to be blurring. And this is going to become a much bigger issue for people across the board in every field.
Yeah. Have you seen outputs from NVIDIA's Cosmos model or from Tencent's Hanyan video?
Show us.
They're correct. Can you show? Yeah, that slide. You might have to go presentation mode. So the one on the far right, I generated yesterday from Hanyan video, and this is with like mixed precision, so it's not even the highest quality output this model can generate. But I think that alone, I showed it to some of my friends without mentioning, because I was actually in Japan recently, so I showed them that and then told them it was AI, and they weren't expecting that. And if you see, yeah, a lot of these other, and the capabilities of things like Hanyan video with like video to video capabilities of, swapping an actor into a scene they were never in, extremely high fidelity.
Yeah, and maybe to touch on like that, I think we get that comment a decent amount of like, hey, like right now, it's not there yet for like humans can still differentiate if you're like aware and are maybe exposed and are in the AI space. I think we look at deepfakes a lot. Like I look at face swaps, and we have this Telegram game right now called AI or Not. And I almost think the addicting aspect of it is that you're not very good. So what this does, it gives images that were generated by our subnet, whether real or AI generated, and you're essentially competing against the subnet. And so you either get it correct or incorrect. And what we found and a lot of the feedback that we've gotten is like, oh my God, I really stink at differentiating between deepfake and real. But agree, probably images right now are probably much higher fidelity than video, but I think there's a lot of really amazing progress happening on the generative video side with Hanyan, Cosmos, VO2, Sora, and that will only get better and better, which will be harder to differentiate. But yeah, I think that goes into kind of like, so we mentioned where we're at now. We have this lead on the open source. We think we have really high performance. We have these consumer applications that are currently live for the distribution of the commodity that we're creating. That Telegram game, we have an agent trying to distribute that commodity as well. And where we want to get to is basically the holy grail of this universal, generalizable deepfake detection model that can do everything. So there's a bunch of steps in between there. And I think what we have next, we launched video. What, Dylan, is about like a month in now? How long have we?
Yeah, about a month. We launched video, in December. And we're kind of moving quickly to incorporate these models that have dropped within the last month. So Hanyan video and the Cosmos model, which don't have any outputs from the Cosmos model, but I encourage everyone to go check it out because they call it a text to world model. and that's because it's so good at generating realistic stuff that it's like basically physics aware. The way things interact with surfaces, how rain affects cars on the road and stuff like that. It's all extremely realistic. And yeah, that's what's coming next. That output that Ken just played, it was a Hunyan video to video output for swapping Keanu Reeves into what is that, Severance.
It's definitely very impressive. Would recommend people check out Hunyan. And then, yeah, like kind of increasingly adding other state-of-the-art models, introducing semi-synthetic, right? Different pipelines of image to video and video to video, more challenging kind of unique semi-synthetic of face swapping, lip syncing, action transfer, etc.
That's
and
real.
Then,
right?
Yeah, this is a real one. I think this is Kodak Black and an Elon face swap, which
Kodak Musk.
Yeah, I think.
Yeah,
yeah.
I think, bit of a sidebar, but I do think it's important to touch on like how we're thinking about the expansions and kind of where we started with just 3 text to image models and kind of progressively rolling out more and more models, asking our miners to generalize further and further. So we're at this point where we've gotten quite systematic about how we decide what models to incorporate into our validator challenges. So we'll actually use that same benchmarking infrastructure to run, a data set that we generate in-house with a proposed model, see how well our miners perform on it. And if they do poorly, it's a good signal to incentivize miners to generalize to that model. So we do have a planned release next week for a model called Deepfake, which is a slightly different architecture than anything we've used before. It incorporates like this super resolution module that allows you to generate really quickly a small image and then upscale it to a larger resolution. And then we also, want to kind of, we started with in-painting. So Ben dropped a picture in chat of an original and an in-painted image. So we'll mask out part of an image and ask AI to fill it. And we want to get into other kinds of semi-synthetics like face swaps, pose transfer, style transfer, things like that. And then eventually, kind of as we mentioned before, take the incentive mechanism or take the output space of our miners and expand it to multi-class. And then eventually asking them for like a heat map of what areas of the image are doctored by AI.
Around 2016, there was a big push at companies like Google for fact checking. In some way, you guys are like the fact checkers for AI.
Yeah, that's an interesting comment. Because I think it's been in the news recently with Meta migrating from fact checking to more of a community notes model. How I think about BitMind is actually more of it's an AI version of community notes. So instead of this algorithm where humans are commenting and providing additional context, you now have 200 plus different miners that are all, high performing based on their accuracy rating, and they're providing their inference, their classification of what you're looking at. And now you have all that data, different opinions, and you can be able to look at that and see, what this AI version of community notes is giving you for additional context on the information you're viewing. But yeah, to wrap it up here, the goal is generalized deepfake detection, as I mentioned. Can we take in any type of modality of input, classify that, and then even expand upon that? Because I think a lot of there's a lot of interest now in observability, explainability, verifiable inference. So I think a lot of that goes into trust as well and reputation. So really, I think that's where we want to get to, of like a strong, authoritative, accurate deepfake detection solution that is best in the market and trusted by consumers. And so we have a bunch of products in the market right now trying to build trust with both consumers and brands. And hope to keep expanding on that. And then, really need to give a special shout out to like the different miner teams that are working on our subnet. I think been really appreciative and impressed by all the work that they're putting in to actually do the classification and compete on this thing to power all these different services that we're building at BitMind.
Hella. I don't think that you can really understate the importance of us figuring out how to ultimately determine whether or not something is real or synthetic as we enter this era of like pure manipulatability with AI. Like it has one way to do it is with cryptography and blockchains, right? We can create hard things using decentralization, but the force of AI to just erode reality is going to be one that we need to fight like a full stop over the next probably the rest of the life of humanity. So I think like what you guys are building here is like so essential for the Bittensor ecosystem. Like I think that it could be used for validation and other types of subnets, but also just for like humanity itself. Like how do we come to agreement about what is real and synthetic? So thank you so much, Ken, for putting this together and coming up on the stage.
No, yeah, thanks for having us.
Great, guys. So we can break into a bit of a broader conversation if we want to do like an AMA. If people want to comment more on this topic, please jump in the chat or come up on stage. Let me know. Raise your hand. You can come up.
Maybe I'll start. Oh,
yeah. Do you want to just read the questions from the chat, Ken?
Yeah. What's the future goals? So Val, right? The future goals, kind of at the end, is this generalized deepfake detection. That's on the AI performance. But what we really want to do is expand. We have this goal of like, right? Can we reach 100 million monthly active users using the products that are powered by this, right? Can we create a very useful product that humans think they need to be able to evaluate what they're viewing? There's already this massive deterioration in trust in media and traditional media, and then I don't know if anyone's on crypto Twitter, like that's a very chaotic place, similar to Discord, right? And to be able to have tools to be able to help you differentiate is where we want to get to. And so the goal is to create the largest consumer application for essentially detection and knowledge verification in the world. Funny to be discussing pictures AI because it looks so real on the screens. Okay, Sats Runner, like the comment, thanks, and appreciate it. How to prepare data sets for semi-synthetics? Yeah, okay. Kazir, great question. So for semi-synthetics, like there are some open source like face swapping models, or there's a lot of open source in painting models as well. And so the idea was that like we would start by essentially creating all these semi-synthetic data sets, trying to do research on open source semi-synthetic data sets and providing that to miners to be able to train on and modify. A really key aspect of this is like, so even if we do create this, the heat map portion will be difficult. What we'll need to incorporate is that masking of the in-painting into the pipeline and having that as an extra attribute in the basically in the data set, so that you can now train on not just binary classification, but also train on identifying the portion of the image or video or segment of audio that has actually been messed up or been touched by AI. Crypto mine. Thank you, sir. Yeah, no, maybe shout out to like a lot of the Bittensor folks. I think really impressed with everyone. Like a lot of the other subnet teams grinding, the miners. Special shout out to the validators. I think they're unsung heroes. They have to deal with 64 different people hitting them up all the time and evaluating. If there's no more questions, like maybe can switch it to what are the big changes that are happening? You briefly mentioned it, Cons, at the beginning, but like, what are the big updates that you're kind of tweaking or improving for detail right now that are about to be released on testnet?